please.
Eh, okay. Hello, everyone. Welcome once again to your study part, where we bring you quality education at a very cheap, affordable rate. Now, here's the catch. We have just about 2 weeks to 3 weeks for your examination. We want to touch on topics surrounding the various branches of physics. Remember, the six aspects which we'll be focusing on still remains number one, mechanics, number two, waves, number three, heat and temperature, number four, electricity and magnetism, number five, modern physics, modern and modern, or let's call it what we call it, atomic physics, atomic and nuclear physics. So let's pick questions that actually what checks out what our preparedness is for these branches of physics for which your UTM examination will be based on. As much as possible, work on your speed. Remember, the whole idea of testing what our knowledge bank is at this moment is to be sure that our speed is top notch. For 40 questions, for 40 seconds questions, let's see how best we maximize using just 40 seconds. For questions that you can tackle in the space of 20 seconds to 30 seconds, let's see how best you're good at it. And for questions that would what require as much time as possible, let's see how best we can manipulate such questions. So, question one for the record. A question like this: electricity. So, I would always indicate what aspect, what branch of physics the question is centered on. Electricity. An equipment whose power is 1500 watts and resistance is 375 ohms would draw a current of question mark. So we know that a question like this, we're making reference to, as much as possible, you're talking about 30 seconds. Within 30 seconds, you should be able to solve this question. Any question whereby you just have one sentence thrown at you should not take beyond 30 seconds solving. So for this guy here now, under electricity, we know that we're making reference to our Ohm's law alongside the formula for power. So if you want to play along that side, you know that it's DC current that we're having. So we're going to work with power being equal to I square R. Power is equal to current and resistance. Current squared multiplied by resistance. 1005 500 is equal to I square 375. Please open your eyes. Jamb is not foolish in their approach to question. You always have that what? Any value you are given, most times, can always what? Divide. Any big value is a multiple of the smaller value given to you. 1,500 is simply a multiple of what? 375. What convinces me about that? I know that 375 multiplied by 2, 0 here, 5 here, and what? 7 here. Observe closely. 750 is half of what? 1,500. So it means that 375 is actually 4 times of 1,500. So why am I saying this? For you to stay clear of your calculator. Stay clear of your calculator. I would have that 4 is equal to I square. Then we have that what? I will be equal to 2 amperes. I becomes 2 amperes. Stay clear of your calculator. At this stage, the temptation to easily pick up your scientific calculator to punch digits is always there. But I can tell you that what? Avoid it at all costs. So a question under electricity, one sentence, and in the space of 30 seconds, you are good solving this. Let's pick the next one. So, question under it. Question under it. We are told that how long does it take? How long does it take a 750 watts heat to raise the temperature of 1 kg of water from 20 degrees Celsius to 50 degrees Celsius? And we're given SHC of water has been equal to 4,200 joules per kilogram per Kelvin. So, question under it. We know that for it, under this aspect, once you are having power being mentioned, once you are having temperature value, mass, most especially. Now, listen to this. In terms of calculation under heat and temperature, relating specific heat capacity and linear expansivity. So anything under expansivity and anything under specific heat capacity. One key thing that differentiates them is the fact that what we always have what we always have mass mentioned. Any question under heat and temperature as a branch of physics, observe closely. Once mass is given, only one formula comes to mind: Q equals MC change in theta, or you are relating it with what? Electricity. Bear that in mind. Check out your question. You should know specifically what topic you can find such questions. So here now you can see that what you are having mass provided in the question, and this, or you are having specific capacity mentioned. You know that you are dealing with Q equals to MC change in theta, or Q equals to ML, or you are relating them with what? Electricity. So this is also a 30 seconds question. Why? We're going to be having that what? Electrical energy will be equal to heat energy. Electrical energy is equal to heat energy. Remember, for electricity in this case, we are going to have power times time should be equal to MC change in temperature, or let's label it as theta 2 minus theta 1. So here, 750 T equals the mass, which is 1, multiplied by specific heat capacity, multiplied by the change in temperature, 50 minus 20. So from here, you're going to see that 750 is to 750 T is to divide 4,200 multiplied by 30. Observe what I did. I did not what? Punch my calculator to multiply these two guys. Avoid that temptation at this point. I know that, oh, fast, you've gotten your answer from your scientific calculator. But note this, there is no scientific calculator in your UTME examination, and that's the attention we're calling. Divide this guy rather by 750. Start practicing it. What you are practicing now, you become familiar with it. You have 750. From our mathematics knowledge, we know that 0 strikes out 0 here, 3 here, and in this guy, you should have 25. And it's a matter of dividing 4200 by 25. 5 strikes out 5 out of this. You have the 5 here, 8 in 24, and 0. 5 would also go again. 5 in 8, you have 1. In 34, you have 7. Then in 34, you have 6. Then you're having what? 4 left, and you have 8. And note, this is in what? Seconds. Note, this is always in what? Seconds. So you don't have minutes as the unit, you don't have what? Hour as the unit. When calculating, you have it in seconds, and you are good to go. But I know that the temptation is always there. Your on-screen calculator is what you should then go ahead using for this part. 4200. So please check out the condition of your mouse. The what? Sensitivity of the mouse you are using. If you have a good mouse that can easily what? Move around the screen, then no problem. You can click your on-screen calculator to what? Do this, something like this. If not, stick to what? Using your pencil. Remember, no biros are allowed anyway. So for those of you always clamoring, oh, what if we're not given papers to work with? Please, you have your photo card with you, which you'll be taking. Do that at the back of your photo card. Or most likely, you'll be given paper. You can easily request for what? A paper to solve inside. So we have our answer for this question. Remember, time is of the essence. Any question you are given, always check out how best you can what? Salvage the timing. Now, check out. Another question is this. Wave. Remember electricity, now we have it. Third question is about wave. How do I know that it's wave? Check this out. We are told that two tuning forks of frequency of frequencies two five six hertz and 260 hertz are sounded close to each other. Close to each other. Full stop. What is the frequency? What is the frequency of the beats produced? So this is a question with regards to wave. This is a question with regards to wave. Now check it out. Two tuning forks of frequencies 256 Hz and 260 Hz are sounded close to each other, and we are being asked to find the frequency of the beats produced. Now it's a question of, are you familiar with the formula for what? Beats. Are you familiar with the question involving beats? If yes, then you know that this is a walkover. In 20 seconds, you have gotten your answer because it's just for you to what? Manipulate the numbers and you're good to go. So check this out. We have that what? Beats is equal to what? Higher frequency, which is F2, minus lower frequency F1. And based on the values you are given, you have 260 minus 256. And the answer certainly will be what? 4HZ. As simple as that. Can you imagine a question this direct for which you might even not have to what? Calculate anything? Please, at this stage, I know that you are getting oversaturated. What should I read and what should I not read? I would implore you to try as much as possible, focus on managing your speed. Trust me, that's what you can do at this stage here now. You want to check out how best you can manage your speed without the use of a calculator. How best can I answer questions? What questions are these that, okay, I know it does not take too much time. And I'm showing you examples of questions. Wave now, you have that, just subtract 260 minus 256, and you arrive at your 4/8. The next question, we dive into the aspect of number 4. So, number 4 has this to say 4 grams of, okay, under what aspect? Nuclear physics. Nuclear physics. Here we are told 4 grams of a radioactive 4 gram of a radioactive material of half-life 10 days is spilled on a laboratory floor. On a laboratory floor. Full stop. We're asked how long would it take to disintegrate 3.5 gram of the material. How long would it take to disintegrate 3.5 gram of the material? So it's a question of what formulas do I have? What formula can I use to actually what? Solve this question? What formula can I use to solve a question like this? And is it something for which it's going to take my time, or literally it would not take my time? So we figure it out. Now, here is the catch. For a question like this, you should bear in mind that we have various formulas under nuclear physics, which would be a centerpiece of radioactivity. One of them is to note that we are told generally that the decay equation has been given as N equal to N naught exponential minus lambda T. What's the meaning of these jargons? We are talking about the amount of radioactive material that will be left. The amount of radioactive material that will be left is always equal to the product of the original radioactive material present. Then you have it exponential raised to power minus decay constant multiplied by the time taken for decay. But along the line, we discovered that there was also another formula called half-life, T half. And T half has always been predetermined as 0.693 over lambda. And guess what they did? They merged these two values together. And they were able to produce a third formula under radioactivity, which signals N over N naught being equal to 1 over 2 raised to power T over T half. So I leave that side. You can see what we have on the board. N over N naught being equal to 1 over 2 raised to power C divided by CR. So among all these values, the best of what we can use, will certainly be the last formula. And I will explain why. Remember, I'm here to what? Enlighten you better as to what you are doing. And please be wary of UTME's question approach. Be careful of how they structure their question. When you are reading, don't read with oversight of, oh, I understand what they are talking. Shebi, it's just the values that we are given. Please, I beg of you, there's no Shebi when it comes to UTME examination. You want to get all your marks. Please note that what the question is talking about, how long it would take to disintegrate what 3.5 gram of the material. But check it out. When we are writing the parameters for all what we have here, you discover that we said N is representing radioactive material remaining. Note the word. It is representing the amount of radioactive material left or remaining. English, what is left or remaining? But here in the question, we are told that how long would it take to disintegrate this value? This is what is used up. So understand the context of what you are being asked. Understand the context of what you are being asked. If we are having that what 3.5 gram has been disintegrated, you can relate it to, okay, what is the mass of radioactive material that is actually left? You can deduce that from it. It's about English twist here. They're not asking you to use 3.5 directly to get this. They are telling you that, okay, relate the mass that is disintegrated with what will be left. So N is radioactive material remaining. N naught is the original radioactive material present. What quantity of radioactive material is present? That's what N naught is representing. Our TF is representing half-life. Our lambda is representing decay constant. And the ordinary T is representing time taken for decay to occur. And your T can be any value, but the secret to using your T value is such that T can always what? Occur, can always happen at any value. It's any time value, usually greater than TF. Meaning that what? The value of small letter T is generally what? Bigger than the value of your half-life. So note that. From here now, you can see that we've taken a question with regards to electricity. Where are you? We have done a question on it so that we know which next question we're picking. We've done something on wave. Here is nuclear physics. So the next question will be on mechanics. So let's finish up our nuclear physics question. Nuclear physics question, let's get through with it. If you're just joining us, welcome to the class. We are looking at question sets and the time management surrounding the questions. Some might be easy. You already know the formulas to use. How best do you avoid using scientific calculators? And how best do you understand the question you have been asked? So all this is just to clear your doubt as to, okay, for those that are not familiar with the context or you've forgotten what the formulas surrounding radioactivity are, here are the formulas, the 3 basic formulas you use for all questions. involving this aspect of decay. You have n equal to n naught exponential minus lambda t. You have t half being equal to 0.693 over lambda, and you have n over n naught equal to half small letter t over capital T half. So among all this, I said that the formula we'll be using will be centered around n over n naught being equal to half raised to power small letter t divided by t half. Now check it out. We are told that 3.5 gram disintegrated. That means we'll have that what? Amount left should be equal to 4 minus 3.5, which will be equal to what? 0.5. Please note that the value of n is never what decayed rather. It's always what is left after decay has occurred. Bear that in mind. The value of n is never what disintegrated, as you are seeing inside the question. It is what is left after disintegration has occurred, and that's why the value we should use is what? 0.5 and not what? 3.5. Having said that, we have that we put in 0.5 here divided by the original value present, 4, equals to 1 over 2 raised to power t is not given. That's what we are looking for. Over t half. What is the half-life? We have 10 days. So we have 10 here. So easily, check this out. You are going to discover that the value here, 0.5, is the same thing as 1 over 2. And here, converting, this can easily turn to 1 over 8. I know some people will be wondering, what magic? Yes, you have that 0.5 over 4 is the same thing as 1 over 2 divided by 4. 1 over 2 divided by, let's place it here, divided by 4. And this is the same thing as 1 over 2 times 1 over 4 when you flip it upside down. Here, you are going to have 1 over 8. So 0.5 divided by 4, you can easily use your on-screen calculator. There's no problem with that. 1 over 8 is equal to 1 over 2 raised to power t over 10. Check this out. I can easily say that what? 1 over 8 is the same thing as saying, check this out, 1 over 2 raised to power 3. And why will I say this? It's simply because I know that 8 is a function of 2 raised to power 3. That's how I'll get my 8. 1 raised to power 3 is also not a big deal because 1 raised to power 3 will give you 1. 2 raised to power 3 will give you 8. And that's why we can easily say that I can bring out the 3 common to both sides. And that's what I did here. 1 raised to power anything will still give you 1. That's why I can easily say that this one is raised to power 3. The 8 is 2 raised to power 3, knowing fully well that 2 times 2 is 4, 4 times 2 is 8. And that's why I am easily bringing out the 3 here. 8 is the same thing as 2 raised to power 3. Indices, mathematics. So here we go. I can compare this side and this side. You know for a fact that what, as far as mathematics indices is concerned, the base can easily cancel out if they are the same, and you can equate the upper values together. And from here, you see that 3 should be equal to t over 10. When you cross multiply, you have that t is equal to 3 times 10, which gives you 30 days. So I know that we wouldn't have used up to this time frame if we're just going straight to solving, but I had to what, do some explanations to clear some doubts. For those of you that are not familiar with this aspect of calculation under radioactivity, that's the reason why I went into details having to what, show you the step-by-step calculation. Please note the English stated. How long would it take to disintegrate 3.5 gram? When questions like this are asked in terms of, okay, if this mass is to be disintegrated, convert it to what will be left after disintegration has occurred. Bear that in mind. What will be left after disintegration has occurred? So if we have 3.5 used up, disappearing, then we have 4 as the total mass given. 4 minus 3.5 is what gave us the 0.5 we are working with. Next question under mechanics. So check this out. Would this fit into a question whereby you are using 30 seconds or you are using 40 seconds? So the choice is yours. Mechanics now. Question on mechanics. We are told this. Question on mechanics. A minute. A spring. That's number 5, if I'm not mistaken. Yes. Mechanics. Here, we're told a spring. In all of these, I have not used a calculator. In all of these, I have not used a calculator. A spring of force constant a spring of force constant 1500 Newton per meter is acted upon by a constant force. By a constant force of 75 Newton. Full stop. Calculate the potential energy. Calculate the potential energy stored in the spring. Calculate the potential energy stored in the spring. So if you're having a question with regards to elasticity, I'm sure you know the topic is under elasticity, Hooke's law. Elasticity, then Hooke's law. Then you should be familiar with what the formula indicates under Hooke's law. So from here now, force constant. What alphabet do we use to depict force constant? We say K is the force constant, 1500 Newton per meter. We are told that a constant force was used, F, being equal to 75 Newton. For us to calculate potential energy, then you should be familiar with the fact that what? First, F is equal to KE, which means that force is always equal to force constant multiplied by what? Extension, which is not given in the question. And we have the potential energy for an elastic material can be obtained by using half Fe. Half Fe. So from here, we know that what? F over K is what our E would represent. So I want to bring this into the picture of things. So I can say potential energy should be equal to half times F times K, F over K, times F over K. Watch what I'm doing. I'm trying as much as possible to avoid the use of calculator. So here now, you see, we have half multiplied by 75 multiplied by another 75 over 1500. Now, you discover this, that based on what we have here, 1500 is a multiple of 75. That's what I keep telling you. When you are giving big numbers, always bear in mind that what you can easily find multiples of such values inside the smaller inside the bigger multiples of the smaller numbers inside the bigger numbers. 75 and 150. You know, 2 is the common value there. 75 will go in 152. But in this case here now, 75 1, 150 is 2, with our 0 we have 20. 75 and 20. Easily you can say that what 5 would divide. 5 will go in 20, we have 4. 5 will go in 75, you have 15. So this leaves us with what? 15 divided by 8. 15 divided by 8. And you have that 1.70. How many times? You have 8. Then just know that what? Usually two decimal places. At this point, having a simple number, you can easily go ahead using your calculator, your on-screen calculator. At least you've reduced this to the lowest minimum. Here now, you have 6, and that will give you 1.87 joules. And you are good to go with picking any of the answers, knowing that what it is to 2 decimal places. And if to 1 decimal place, as we have in the options, you can easily say that this is 1.9 joules. Please, I am telling you all this for you to prep your mind about your time management. The secret to passing this examination is embedded in your ability to manage your time. Please determine what questions are taking your time and what questions are good to go in terms of your speed level. Don't use all the time in the world practicing your question. Let's go to questions that necessarily would not involve calculations. We have looked at calculation questions for the 5 aspects. Let's look at questions that necessarily would not involve calculation. So let's see. We are told this. Check this out. Under mechanics, let's go for mechanics first. Okay, non-calculation. Mechanics, number 6. Mechanics. So here we go. This is a body of weight, W Newton, rests on a smooth plane, inclined at an angle theta to the horizontal. Inclined at an angle theta to the horizontal. What is the resolved part? What is the resolved part of the weight in Newton along the plane? So you should understand that what sometimes they want to see how best you can actually what take into context your resolution of vectors. Remember, we've had instances dealing with resolution of vectors using your SOHCAHTOA in the picture of things. How best can you resolve and play with your angles when given? Example of this is what we have under this mechanics question. This is simply what frictional. Okay, no, yes, it's under friction. We have it under friction in the context of friction. Question of friction. Yes, you talk on the broader level. You talk about dynamics. If you don't know where dynamics is coming from, I'm sure you are familiar with Newton's law of motion. Anytime we are emphasizing Newton's law of motion, then have this at the back of your mind. An application of Newton's law of motion. And why am I telling you that it's Newton's law of motion? Remember that among Newton's law of motion, we are told that what? F is always equal to ma. That is always applicable This is only applicable if you're having that what? Frictional force is equal to 0. If friction is equal to 0. If you have that what? Friction is not equal to 0, then you must respect the fact that F minus frictional force is equal to MA. So this is the genesis of how some of these aspects came about. So bear in mind, Newton's law of motion is what gave birth to this aspect of question. So if we are to now resolve, they are talking about inclined plane here, a smooth plane inclined at an angle of theta to the horizontal. How do we represent this? For those of you not familiar with friction or you don't like friction, here's what the diagram looks like. An inclined plane is slant. You have the horizontal surface. We are giving an angle to the horizontal, which is theta, present here. Now, the body will be resting on the plane this way, such that the weight is acting perpendicularly downwards. The weight of the body always acts straight down. W, which is the weight, will always act straight down. But the challenge is this. Although Newton's third law says to every action, there's an equal and opposite reaction. However, it does not what always act. Your reaction does not always act vertically opposite to your weight. It always acts vertically to the plane given. So if I have an horizontal surface this way and I have a body resting on it, it means the weight will be acting downwards, W. The normal reaction, in this case, R or N, whichever one you're using. R, in this case, would be acting vertically to it. But the moment I have an inclined plane, this is how the plane is to the horizontal ground. I'll be having that what? The normal reaction, R, will be acting at this angle while you have your weight acting this way. You always have it acting 90 degrees to the plane in question where the body is resting. Bear that in mind. Put that in mind. So you don't always have it exactly vertical to the weight. To every action, there's equal and opposite reaction. How is the reaction acting? So that has been explained now. So you can see that what? Having our weight downwards here, we can always say that the normal reaction should be acting slant. You should have that the normal reaction should be acting slant this way, and check it out. If I should have my normal reaction R this way, based on resolution of forces, remember, the resolved part of the weight is what they're asking you. I can trace down this line this way. I can bring down the R towards this side such that I have my R extended downwards. I can say that this R has been acting in this direction, and I would have, here is what we are looking for, resolved part. This is the side we are looking for. This theta here, based on mathematics principle, is actually transferred to this side here, theta. This angle, theta to the horizontal, is transferred to this side here. It has been proven mathematically. So now is not time to start explaining that. What triangle are you having for these mechanics? We're having a broken line representing our reactant side. We have the slant side representing our, okay, let me draw it exactly the way we have it. Please note that this is the longer side. So don't mistake the weight as being the opposite. No. You have that the weight is the longest side here, the hypotenuse. Your weight is representing the hypotenuse. Your R, reactant, is representing the adjacent, while the resolved side, the resolved part, would represent the opposite to the angle given. Your theta to the horizontal, in terms of the weight component, is always to this side here. So as such, you have that this side is the opposite. We want to find the resolved side in terms of the weight. So we can easily say that here, sine theta is always equal to opposite over hypotenuse. Opposite over hypotenuse. So meaning sine theta is equal to the resolved part divided by our weight. When we cross multiply, you get to see that your resolved part is simply W sine theta. That's the answer, W sine theta. So imagine a supposed non-calculation question, and we are calculating angles from it. We are using sine theta, we are resolving and all the likes. Please bear in mind, some questions might appear non-calculation, but there are calculations embedded. If not, you'd end up doing many more, and you don't want to put that up. This instance here now, the moment you are seeing an angle involved, they expect you to calculate something. Something should be calculated. And let me bring to your listening audience that anytime, I repeat, anytime an angle theta is given, you can always calculate the coefficient of friction. The reason why we don't have any use for coefficient of friction under this question is because, check out, they said it is a what? Smooth plane. Anytime you're having a smooth plane, it means friction is zero. You don't have what? Friction, or you say friction is negligible. Whatever the value of friction is, you can always what? Neglect it, ignore it. So once you are given a smooth plane, something is always up there. It means that what? Your frictional force is negligible, equal to zero if you put it that way. And that's why we are saying that what? Note that in other questions, you can be asked to determine the coefficient of friction. And guess what we use? For non-calculation questions, we assume it as tan theta, tan angle to the horizontal. We are good to go. Tan of the angle to the horizontal will provide your coefficient of friction. And what symbol do we use for coefficient of friction? Mu. So bear this in mind. So when you see a question under this aspect, non-calculation, see what we have done, how we arrived at the resolved parts, SOHCAHTOA, as the context is. Okay, we've done and dealt with what? Mechanics. Let's pick another question, now this time on wave. Remember the various aspects. We look at some questions involving calculations and some questions in the context of no calculation. So, non-calculation, don't forget. Here, number 7. Let's raise our hands up. Number 7. Remember, there's limited time for us, much explanations to do. That's why you see that we are not going 20, 30 questions in 1 hour. The whole idea is the understanding our students achieve. Let's make the questions minimal, but yet let's focus on the impact of the questions. So look at this guy. We're asked this instance. Which of the statements, which of the following statements Okay, what topic? We talk in terms of magnetism. Remember, the first one was electricity. So you can have magnetism as the question. Magnetism. We are told of the following statements which of the following statements is correct about the Earth's magnetic field? A has this to say: the angle of dip. The angle of dip is the angle which a freely suspended magnet makes with the vertical. B, the angle of inclination, the angle of declination is the angle between the magnetic meridian and geographic meridian. The next is saying that the angle of declination is the angle which magnetic compass makes makes hold on, no, let me mix up. Makes with the magnetic meridian. Then the last option, D. D. The angle of inclination is the difference between the angle of dip and the angle of declination. So much stories, they expect some level of accuracy from you. Much stories, but they expect some level of accuracy from you. So here is it. There are always three properties which we consider anytime we are talking about the Earth's magnetic field. Three properties to always consider. Number one is the angle of declination. The next is the angle of dip. And the last is the horizontal component. Angle of declination, also angle of variation. Angle of dip, angle of inclination. So bear that in mind. Now check this out. As far as all these options are concerned, angle of the key one which you'd always have is always the angle of declination. And check out which one matches all the options provided. You'll always have that as far as the Earth is concerned, you have it such that geography students are taught such that you are having your south here, you're having your north here, you're having your east here, you're having your west here. What you are being taught is what we describe as the geographical meridian. Geographical meridian, meaning the position of various parts along the earth, talking about geography. But talking about the magnetic meridian, magnetic meridian, we have that if the earth is like this, okay, pardon my diagram, it's bulging out on the sides. So you have that the earth is like this. It's expected for you that what the earth is pictured to have a magnet component in it, such that the influence of the magnet is located slant along the geographical north and south. And the south pole of the Earth's magnet is located close to the geographical north, while the what? The north pole of the Earth the north pole is located at the southern geographical meridian. Please note this too, because it's a bit confusing for those that have not read that part or are not even interested. Remember, this is an SS3 topic for which some schools will teach you, some will just breeze through it. Put in mind, so that you don't mix up these three words, properties of the Earth's magnetic field. Always bear in mind that we have what we know as the geographical meridian, what you know normally in your geography or what you know in your mathematics. North is up, south is down, east is to your right, west is to your left. Mathematics, no problem. But as far as physics is concerned, we believe that the earth has a magnetic component such that the magnetic feature of the earth is that we have the earth having a magnet embedded in it. And the magnetic field is such that the south pole is located up, while the north pole is located downwards. So the north pole of the earth is close to the south region in terms of the geographical position, while the north geographical position is close towards the south pole of the earth's magnet. And you discover that when we merge these two together, you are going to have that what? You have a circle, you have the north, here geographical north, and I can easily draw my magnetic meridian. So I'll be writing South Pole here. So you see what happens. The angle between them is what we call angle of what? Declination. So this theta here is what we are labeling angle of what? Angle of declination. Note, angle of declination. So check out magnetic property and geographical property. That brings to bear that among all these options, the first instance is saying A, the angle of dip is the angle which is freely suspended, which a freely suspended magnet makes with the vertical. Check very well. This is the vertical. The geographical meridian is the vertical. The South Pole is what we are having at the upper region. There's an angle in between them. So they are making reference to what? The angle of declination, not the angle of dip. Angle of dip is never made with the what? Vertical. Bear that in mind. Angle of dip is not made with the vertical. So that cannot be the answer. The angle of dip is always considered from the equator, such that we can say that here, the angle of dip at the equator, your angle of dip equals 0. Here, at North Pole, at the north, angle of dip equals 90 degree. The south, at the south, you have that angle of dip equals 90 degrees. So bear that in mind where angle of dip comes in. It's not made with the vertical. When you are considering it, you don't consider towards the vertical. It's your angle of declination. That's why I'm putting in the names. Angle of declination has a second name, angle of variation. Angle of dip has another name, angle of inclination, increasing. So we have that B is saying the angle of declination is the angle between the magnetic meridian and the geographical meridian. Very accurate, as I've shown you in terms of the magnetic meridian of the Earth and in terms of the geographical meridian. C is saying the angle of declination is the angle which the magnetic compass makes with the magnetic meridian. No, you don't have it. It's actually combining the geographical meridian and the magnetic meridian. The last one is saying that the angle of inclination, which is the angle of dip, is the difference between the angle of dip and inclination and declination. That's contradictory. Why? Angle of dip is also called angle of inclination. So you cannot have that. What? Angle of inclination is now a separate entity from the angle of dip. So you can see a twist as to what you need to know talking about your what question under magnetism. Some breakdowns under it. You want to read more on it because I know that some people are not what familiar with this concept. Please, as much as possible, speed is of the essence. A question like this, when you read it twice max or thrice max, you should be familiar with, oh, I can answer this question or I can't answer. Every bit of what you are doing, I would always employ you. Do the non-calculations first. You maximize the time frame you have. Till I come your way, I remain Mr. Femi. Bye for now. I